Hi everyone, I wanted to take a minute and recap over Newton's 3 laws. So we're going to look at each of his 3 laws and some information that's super important about each one of the laws. Okay, so we're going to fill out some notes here to help you. Okay, so first we're going to start with Newton's first law, which is also called the law of inertia. So remember that inertia is one of our very important vocabulary words that we need to know to help us understand each of Newton's laws. Okay, so inertia is the tendency of matter to resist any change in motion. Okay, so this goes directly in line with what Newton's first law says, that an object at rest stays at rest, and an object in motion stays in motion unless the object is acted on by an unbalanced force. Okay, so this is basically just the definition of what inertia is if you really stop and think about it. Okay? So let's come back up here to what else we can call Newton's first law. So Newton's first law is also called the law of balanced forces. Okay, so when we're looking at an example here for Newton's first law, we're looking at a ball rolling across the floor. Okay, so if the ball is sitting there, it's not going to move. It's never going to move unless an unbalanced force acts on it. So currently, all the forces are balanced. Okay, that's why it's not moving. Okay, the same thing with a ball that's in motion. A ball that's in motion is going to stay in motion in the same speed, in the same direction, unless it's acted on by an unbalanced force. So it's going to stay the same speed and same direction. Okay, again, because it's balanced. Okay, so unless I come along and kick that ball, or the friction applied to this ball makes it stop, if none of those things happen, it's because of its inertia, it's always going to continue on in the state that it's in. Okay, so let's come back up here and look at the definition for our balanced forces. Balanced forces are forces acting on a mass that are equal and opposite. Okay, so when this ball is sitting here, it's not moving. It has a force pushing up on it from the ground. It has gravity pulling down on it, and that's about it. Okay, so these two are equal and they're opposite, so everything is balanced. Okay, the same thing with this ball that's rolling. Okay, the acceleration that it has in the forward direction is equal to the friction force in the other direction, so it ends up being at the same speed. So it does not have acceleration because these are balanced. Okay, so it ends up with the same speed going in the same direction. Okay, if it hits a rock, the rock's going to apply an unbalanced force which would cause it to change its speed or change its direction. But when everything is balanced, it has inertia going at the same speed, the same direction. It doesn't want to change. Okay, so let's look at Newton's second law. Newton's second law is also called the law of acceleration. Okay, the law of acceleration. This is also called the law of unbalanced forces. So just like we looked at in the first example, when the forces are unbalanced, then we have acceleration, a change in direction or a change in speed. Okay, so for this law, it's very important to understand the vocabulary word of what an unbalanced force is. Unbalanced forces have forces acting on the mass that are not equal. Okay, so these forces are not equal. So we have forces in one direction that are not as strong as another direction, causing the object to move. Okay? So Newton's second law says an unbalanced force causes an object to accelerate in the direction of the force. Okay, so Newton's second law is where we have some math equations to help us understand it. So this is force equals mass times acceleration. So if we look at the example here, force equals mass times acceleration. So we have a wagon with a small mass in it, and we have a wagon with a large mass in it. If they're both pushed with an equal force, the one with the smaller mass will accelerate more greatly than the one with a larger mass because the forces are equal. Okay, so that is what this equation is basically saying. It's the relationship between force, mass, and acceleration. Okay, Newton's second law also gets into weight versus mass. So we have two more important vocabulary words. Remember that weight is a measure of the gravitational force between the object and the Earth or any other planet. Okay, so remember, because weight is based off of gravity, if we leave the Earth, our weight can change. Where mass, on the other hand, is a measure of the amount of matter that makes up an object. The amount of matter that something has never changes. It's always the same. It's a property of that object that is unchanging. Okay, so we do have a formula to help us calculate the weight of something. It's weight equals mass times gravity. And we're always going to use 9.8 to calculate G, to use as G to calculate the weight, unless you're on a different planet where the gravity is different. So that brings us to Newton's third law. Okay, Newton's third law is also called the law of action and reaction. Okay, it's also called the law of forces acting in pairs. Okay, for Newton's third law, we need to remember what it says. So for every action, there is an equal and opposite reaction. Okay, so that's why it's called the action-reaction law. So when we're looking at Newton's third law, it's all about how the forces working in pairs cause a reaction to happen. Okay, so if I have two kids on skateboards and they're pushing on each other at this point, they're both going to move outward away from each other. Okay, so the action is the push, the reaction is the move. So notice that the arrows are always going to be pointing away from each other when we're looking at our action-reaction force pairs. Okay, so some important things to remember about Newton's third law is that a friction force can change the motion, and a friction is a force that resists motion. Okay, so we do see friction in Newton's second law and Newton's first law, so it is important that we understand what is friction and how it works in relation to these laws. Okay, Newton's third law is also all about momentum. So momentum is a property of a moving object has because of its mass and its velocity. Okay, and that brings us to the law of conservation of momentum, which says that the total amount of momentum of a group of objects does not change unless unbalanced forces act on the object. Okay. So that's just a quick recap of the things we've been talking about with each of Newton's laws. So take a look at that, use this as a graphic organizer to help you as you study and prepare for your exam over Newton's laws. All right, have a great day.